Hello class, this is section 7.1, linear equations. So we're going to learn to solve a linear equation, identify a linear equation as a conditional equation, an identity, or a contradiction, solve a literal equation or a formula for a specified variable, use a linear model in an application. Alright, an algebraic expression involves only the basic operations of addition, subtraction, multiplication, or division, except by zero, or raising to powers or taking roots on any collection of variables and numbers. For example, an algebraic expression could be 4x minus 7, or the square root of m plus 3, or even x times y to the third times z all over k. Those are all algebraic expressions. An equation is a statement that two algebraic expressions are equal. A linear equation in one variable involves only real numbers and one variable. For example, 4x minus 7 equals 8, and 5k plus 3 equals k plus 1 are both linear equations. An equation in the variable x is a linear equation if it can be written in the form ax plus b equals c, where a, b, and c are real numbers with a not equal to 0. A linear equation in one variable is also called a first-degree equation. If the variable in an equation is replaced by a real number that makes the statement of the equation true, then that number is a solution of the equation. An equation is solved by finding its solution set, the set of all answers. Equivalent equations are equations with the same solution set. So, let's look at the addition property of equality. For all real numbers a, b, and c, the equations a equals b and a plus c equals b plus c are equivalent. The same number may be added to both sides of an equation without changing the solution set. So adding a number to both sides is not going to change the solution set. For all real numbers a, b, and c, where c is not equal to 0, the equations a equals b and ac equals bc are equivalent. Both sides of an equation may be multiplied by the same non-zero number without changing the solution set. Okay, so I can add to both sides and it doesn't change anything. I can multiply to both sides and it doesn't change anything. Step 1 to solving a linear equation in one variable. The first thing we need to do are clear fractions. We want to eliminate any fractions by multiplying both sides of the equation by a common denominator. Step 2, we want to simplify each side separately. Use the distributive property to clear parentheses and combine like terms as needed. Step 3, we want to isolate the variable terms on one side. We will use the addition property of equality. Step 4, we want to transform so that the coefficient of the variable is 1. Use the multiplication property of equality. And step 5, we want to check. We want to substitute the solution in the original equation. So let's solve 2 times x minus 5 plus 3x equals x plus 6. Okay. First thing I'm going to want to do is simplify each side of the equation independently here. So the first thing I'm going to do is use the distributive property to distribute this 2 to the x and the 2 to the negative 5. That's why I get 2x minus 10, because 2 times negative 5 is 10, plus 3x equals x plus 6. Okay. Now, I need to combine any like terms on both sides. Now the right-hand side doesn't have any like terms. All I have is an x and a 6. But on the left-hand side, I can combine the 2x and the 3x to give me this 5x. So I've simplified it down now to 5x minus 10 equals x plus 6. Now, I want to get x by itself. So what I'm going to do now is kind of focus on isolating an x and then bringing the other x around to it. So I'm going to try to keep this 5x over here on the left side. I want to get it by itself, so I'm going to add 10 to get rid of this negative 10. I'm going to add 10 to this side as well. So essentially what I've done here is 5x minus 10 plus 10 to cancel these terms out and leave me with the 5x equals x plus 6 plus 10. Now that simplifies obviously to 5x equals x plus 16. Okay. Now what I need to do is I need to get my x's together. Okay. So what I need to do is subtract the x from this side over to this side. Okay. So I get 5x minus x equals x plus 16 minus x. And obviously these cancel, or if you want to write it this way, these cancel. So that I'm left with 5x, if you want to write an intermediate step, 5x minus x equals 16. 5x minus x is 4x, so 4x equals 16. We're almost there. But I still want to get x by itself, and I have this 4 to deal with. So what I'm going to do, the 4 is multiplied here. I'm going to do the opposite. I'm going to divide it. So I'm going to divide by 4 on both sides. Okay, so I get 4x divided by 4. That's just going to cancel down to an x. And 16 divided by 4 is 4. Okay, so here's my solution. X equals 4. Now, if I want to, I can go back and check that the solution set is 4 by substituting 4 for x in the original equation. Okay, so let's see if we can go back and do that. So if I come back to my original equation here and I substitute 4 in for it to see if it works, so I'm going to put 4 everywhere there's an x. Now if I simplify this side, it's going to be 2 times negative 1 plus 3 times 4 is 12. 4 plus 6 is 10. 2 times negative 1 is negative 2 plus 12 is 10. Negative 2 and 12 is 10. 10 equals 10. That's a true statement. So clearly 4 was the correct solution. Now let's solve a linear equation with fractions. So here I have x plus 7 over 6 plus 2x minus 8 over 2 equals negative 4. Now, first thing that I want to do is get rid of the fractions. In order to do that, I'm going to multiply by the least common denominator. Okay. Now, here I've got 6. I've got a 2 in the denominator here. So, it's almost like when you're adding and subtracting fractions, you want the same denominator. But here we want something that'll basically multiply the whole equation and get rid of all the denominators. Now 2 is a factor of 6, so if I multiply this whole thing by 6, the 6 should go away and the 2 should go away. So that's what I'm doing here, multiplying the entire thing by 6. And when I say the entire thing, I mean we're basically multiplying the entire thing by 6. And I guess an x probably isn't the best thing to use there, but we'll use a simple multiplication sign, like a dot. Okay. Now, so that means we multiply the left-hand side of the equation by 6 and the right-hand side of the equation by 6. And when we do this, essentially that means we're multiplying every term on the left by 6 and every term on the right by 6. The only term on the right was the negative 4. Okay. But here when I do 6 times x plus 7 over 6, this 6 is going to cancel. And when I do 6 times 2x minus 8 over 2, the 6 and the 2 cancel down to a 3. So that cancels down to a 3. 6 divided by 2 is 3. Okay, so I'm left with x plus 7 plus 3 times 2x minus 8 equals negative 24. We get negative 24 because 6 and negative 4 is negative 24. Now, we get to continue on. We're going to use the distributive property here. So the 3 is going to distribute to the 2x, and the 3 is going to distribute to the negative 8. And that's where we're going to get our 6x minus 24 here. So that's where that piece came from. So we have overall x plus 7 plus 6x minus 24 equals negative 24. Now, we need to combine some like terms. Okay, well, let's combine the x and the 6x. That gives us the 7x. And then let's combine the 7 and the 24, or the negative 24. Don't forget that sign out front, the negative 24. Negative 24 plus 7 is negative 17. Okay. Now we need to get the x by itself. So the next thing we're going to want to do is add 17 to both sides. Okay, so if we add 17 to both sides, it simplifies down to 7x equals negative 7. And then we're going to want to get x by itself, so we're going to divide by 7. So obviously the 7's cancel here. Negative 7 divided by 7 is negative 1. Negative 1 is our solution, and as always, we can go back and we can check that negative 1 solution in our original equation to see if we wind up with a true statement. Now, there are different types of linear equations, okay? So you can have a conditional one, which gives you one solution with the final line when solving being x equals some number. You can wind up with an identity statement, which means that there are infinite numbers of solutions, which means that you wind up with a true statement at the end, such as 0 equals 0, or you don't always get 0 equals 0. You could get something like 18 equals 18. You just need a true statement. As long as this statement holds true, you have infinite number of solutions, okay? You could also end up with a contradiction, which means that you have no solutions. And that's usually when you wind up with a false statement, like 0 equals 1. 0 doesn't equal 1. Or maybe you wind up with 5 equals 17. That's also a false statement. Not true. If it's not true, it comes up with a false statement at the end. That's a contradiction, and then you have no solution set. Okay. So let's try one of these contradiction ones. So when it starts out, you're not going to know it's a contradiction. It's just going to look like a regular linear equation here. So here we have 3k plus 4 minus 2k equals k. Okay. Well, let's go on and solve it like we normally would here. Okay. So we would combine like terms here. So 3k minus 2k is k. So we have that k plus 4 equals k. Okay. And then we're wanting to get k by itself, so let's subtract this k over, and that's going to wind up giving us 4 equals 0. Or you could follow the solution steps here as well. They work just fine. But 4 equals 0, that's not right. 4 doesn't equal 0. So because the result is false, the equation has what we call no solution. The solution set is the empty set, which is what this represents. If you've never seen that before, that is the empty set, or essentially the null set. So the original equation is a contradiction, and we have what we would just generally call no solution. Okay. Let's check out what an identity would look like here. Okay, so for an identity one, let's solve it through. So the first thing I'm going to do is simplify. 3k minus 2k is k. You wind up with k plus 4 equals k plus 4. And you should already kind of tell that something's up there because both sides are the same. Let's say I subtract a k off of this side and subtract it over here. I'm going to wind up with just 4 equals 4, which is a true statement. And what that means is that the solution set is all real numbers, and the original equation is an identity. It basically means I can plug anything I want to into k here, and the solution will still come out to be true. So I could plug 0 in for k, I could plug 1 million in for k, and it still turns out to be a true statement at the end. So it has an infinite number of solutions, or its solution set is all real numbers, anything you could put in. All right, now let's look at literal equations and formulas. An equation involving variables or letters such as y equals mx plus b is called a literal equation. Formulas are literal equations in which more than one letter is used to express a relationship. It may be necessary to solve for one of the variables in the formula. This process is called solving for a specific variable. Now, step 1 says if the equation contains fractions, we're going to multiply both sides by the least common denominator to clear the fractions. Step 2, we're going to transform so that all terms with the specified variable are on one side and all terms without the variable are on the other side. Step 3, we're going to divide each side by the factor that is the coefficient of the specified variable. So let's solve the formula here. P equals 2L plus 2W. This formula should look familiar because this is the formula for perimeter. But we want to now solve it for length. Okay. Typically the formula for perimeter is 2 times the length plus 2 times the width gives you the perimeter. But hey, maybe we want to know and solve just for the length here. Now, first thing we're going to do is we want to get that L by itself because that's what we're solving for. So we're going to subtract 2W from both sides. So we wind up with P minus 2W equals 2L plus 2W minus 2W. And these obviously cancel themselves out. Okay, so now we're left with P minus 2W equals 2L. We need to get rid of the 2 in front of the L, that coefficient. So we're going to wind up dividing both sides by 2. Okay, and that's exactly what we do here. We have P minus 2W over 2 equals 2L over 2. And obviously these 2's cancel out. So P minus 2W over 2 equals L. Or if you wanted to, you could simplify it down to P over 2 minus W equals L. Either are fine. But now we have isolated the L and solved for that specific variable. Now let's look at models, or mathematical models here. A mathematical model is an equation or inequality that describes the relationship between two quantities. A linear model is a linear equation. The relationship between degrees Celsius, C, and degrees Fahrenheit, F, is modeled by the linear equation F equals 9/5 C plus 32. Let's find the Fahrenheit temperature that corresponds to 30 degrees Celsius. Okay. So, because C equals 30, the equation becomes, instead of F equals 9/5 C plus 32, we substitute the 30 in for the C. So it becomes F equals 9/5 times 30 plus 32. Okay. Now, all we have to do is simplify at this point. 9/5 times 30 is 54. 54 plus 32 is 86. Okay. So F equals 86 here. And we have done our temperature conversion. Now, a British person would probably tell you that's a heat wave. A person from here in South Carolina, especially in the Aiken area, would probably tell you that is a very cool summer's day. Anyway, the Celsius temperature, 30 degrees, corresponds to 86 degrees Fahrenheit. Now, like I said, a pretty cool summer day. That completes this lecture. If you have any questions, send me an email. Otherwise, I'll see you during the next lecture.